Okay, let's continue how to deduce the order of reactions, initial rates method or half-life method. All right, so there are two main methods that we use to deduce the order of reaction. Let's do a few practice questions to actually see how this works. All right, so we see here a table that's given to us, and that tells us like 4 different experiments. When we change around the concentration of the reactants, what happens to the rate? All right, so is this a initial rates method or half-life method? I hope it's pretty clear to you is initial method because we won't be able to see the half-life from a table, right? Okay, so let's look at the typical questions. A, right, how does the rate of reaction depend on the concentration of each of the reactant? So when we look at the table using inspection method, comparing experiment 1 and 2, right? So let's look at experiment 1 and 2. Okay, so experiment 1 and 2, when you keep Br minus and H plus constant, right? And you increase the concentration of bromate by 2 times, all right? We see that the rate also increased by 2 times. So the order of reaction with respect to bromate is 1. Okay, so if we compare experiment 1 and 3, so I'm gonna just use a different color. 1 and 3, what is being kept constant? Bromate is now kept constant. All right, H plus is still kept constant. And we see that the Y is doubled. What happens to the rate? It also doubles. All right, so basically the order of reaction is also directly proportional to Br minus. So now we compare experiment 3 and 4. I'm going to use yet another color. All right, now we keep bromate and bromide constant. We double the concentration. You can see that the initial rate increased by 4 times. All right, if it increased by 4 times when the concentration is only doubled, it means that the order with respect to H plus is actually 2, second order. All right, so to write the overall equation, rate equation, you simply put it all in, raised to their appropriate orders. All right, so 1 and 1 for the bromate, bromide. Then for the H plus, we have 2. All right, the overall order, you just add them all up, you get 4. And then how do you find the actual value of the rate constant? All right, so we basically substitute the initial concentration and the initial rate of any experiment. All right, so we can just pick experiment 1 and just substitute in all the values. Okay, you can try doing that yourself. Okay, so let's look at another practice question. So they will ask you to write the rate equation, and we're going to demonstrate here a calculation method, which is different from your inspection method, right? For calculation method, we're going to let the rate equals to concentration of ClO2 to the power of A and hydroxide to the power of B. All right, and then when we substitute in the values for equation 1 on top and equation 2 below, we will actually be able to solve for A by taking the log of both sides, and we bring down A and we realize that A is 2. So the order of reaction with respect to ClO2 is 2. Likewise, we're going to choose experiment 2 and 3 to help us to calculate, because then your ClO2 can be cancelled out, right? Since it's kept constant. All right, so for the initial one, OH was kept constant and it was cancelled out. All right, so we find that order of reaction with respect to hydroxide is 1. So now we can write the overall rate equation. And then part C asks us to calculate the rate constant. So like what we say in the earlier practice question, we basically substitute, experiment 1's data into the rate equation, and we find the value of rate constant. Okay, so part D asks us to determine the initial concentration of OH minus used for experiment 4. So basically we sub everything in, including the rate constant, and we are able to find the concentration of hydroxide in experiment 4. All right, and then the last part asks, suggest with a reason what will happen to the rate of reaction if the concentration of ClO2 is doubled, concentration of OH minus is tripled. So according to our rate equation, right, we just actually multiply the ClO2 by 2 and the concentration of OH minus by 3. And we end up with a 12 times increase in the rate. All right, so the presentation for this method is rather important, but you guys don't have to do it. So you just need to know how to calculate the number of times it increases by. All right, so let's look at one more practice question. Okay, so this question is on hydrogen peroxide reacting with iodide to liberate iodine. All right, explain the purpose of water added in each experiment. Okay, so you realize instead of now, right, giving you the concentration, now we are giving you the volume of the reactants. So when we give you the volume, right, and when you vary the volume, that's going to change the total volume, right? So each of the reactants concentration will actually change. All right, so in order for the volume to be directly proportional to the concentration, water is added to keep the total volume constant. All right, so that we can make this relationship be true, right? Which is volume of the reactant is directly proportional to the concentration. All right. You also note that they actually gave you the time taken instead of the rate. Okay, so we're gonna use this rate is directly proportional to 1 over time. And then we are gonna start doing our inspection method. So when we compare experiment 1 and 2, everything was kept constant. Water is used to top up, and then peroxide is doubled. What happens to the rate of reaction? It also doubles, right? Because 1 over 14 changed to 1 over 7. So the rate of reaction also increases by 2 times. So the order of reaction with respect to peroxide is 1. All right. And next, when we compare experiment 1 and 4, right, 1 and 4, let's change another color. 1 and 4, peroxide now is kept constant. Iodide is kept constant. H plus is doubled. You can see that the time taken stays the same. So the order is 0 with respect to H plus. All right. Last but not least, we're going to look at experiment 1 and 3. 1 and 3, again, peroxide kept constant. H plus kept constant. I minus is doubled. What happens to the rate? It also doubles. All right, so that tells us that order of reaction with respect to I minus is 1. Okay, therefore, our rate constant will just be I minus to the power of 1 and hydrogen peroxide to the power of 1.